Can you imagine corrosion happening in a pharmaceutical, highly hygienic system? Sounds frightening, right? I will explain the indication, the quality checks, and a possible root cause for this. Within another video, I was introducing to you the possibility to rate the quality of a stainless steel surface in a quantitative way using the ASTM G61 method for pickling potential measurement. Today, I would like to explain how this method is being used in a real case scenario in the rating, quality rating of a tubing system, or let's say tubing. For that, in order to do it, I brought you some samples here, and when you take a look, or let's see, when I take a look at this sample, to me it seems pretty okay. However, when you a visual inspector in our QA, you will figure that it's not really as shiny as the other samples you're seeing. Why is that? What is the root cause about it? Is there any? Is it harmful for the later application? Probably it's a highly hygienic pharmaceutical tubing system in which this piece of tubing will be used. So in order to investigate more, what we did is we were then pickling this sample. Yeah? This is another dimension, but that doesn't matter. And when you do the pickling, you will figure it's turning gray. That's what it always does. Yeah, it's a bit dull. Yeah, but this grayish surface is something which is certainly extraordinary and which is not standard. So something is happening here. The question is what? And the what is clearly to be defined. There is a carburization happening. So what is that? A carburization is when the tube which is being produced, let's say in a seamless production step, will be later on annealed in a furnace. When, due to the preparation for this step, the tubing is not completely clean but still has some, let's say, grease on it, some lubricants, which is the residual from this manufacturing process, then these lubricants will be burned in the furnace. And what remains on the surface is carbon. Due to these high temperatures at roughly 1000 degrees Celsius, the carbon will diffuse into the structure of the alloy. And this is what's happening then. You see carbon being diffused in the grain structure of the alloy and taking out the available chromium and form chromium carbide in these alloy. And that's what you see here on the top. So you can say, so is it a problem? Yes, it is, because the chromium itself is not available to protect the surface anymore. And what is the actual quantitative effect on this? We have been taking the bright finished version and did a ASTM G61 test that you can see up here. And you will figure that you have roughly a CPP value of 250, which is actually pretty low. Further down the road, when you start to take off the surface, which we do by electropolishing it, first, let's say 10 micrometer that we take off, it will reach a value of roughly 300. So it's getting better. We take off contaminated surface structures and we will get a higher CPP value. When you take down 20 micrometer, you will figure that you will end up at roughly 450 ppm, millivolt voltage for the CPP value. So this is then the final value, and you can figure that you almost double the CPP value for this alloy, which means that you more than or roughly double the corrosion resistance of this material. And when you have a certainly probably critical application, then yes, this effect will certainly be harmful. So here it's really the correspondence between visual inspection, the further testing, the estimation, the determination of the root cause that is saving your application. But this is certainly only one case study that I wanted to explain here. Well, I hope I could give you some indication on the method, on what is being done in QA in order to secure the quality and how we do it. Not much more to say, then thanks a lot for your attention, and I'm certainly very happy to receive further questions. If you have them, please direct them to us, and I would be happy as well about the fact that you subscribe to our YouTube channel. Thanks so much, take care and stay healthy.